The star Betelgeuse, a red supergiant located in Orion's constellation, has long fascinated astronomers and skywatchers because of its enormous size and luminosity. If Betelgeuse were positioned where our Sun resides, it would extend all the way to the orbit of Jupiter, underscoring its colossal dimensions. Despite being situated about 642 light-years from Earth, its massive size makes it one of the brightest stars visible to the naked eye. Recently, however, Betelgeuse has exhibited odd behavior. For instance, it has gone through bizarre cycles of dimming and brightening, which many scientists believe indicate that the star is nearing the end of its life. Renowned physicist Brian Cox recently made an eye-catching remark that Betelgeuse is on the verge of a catastrophic explosion, expected to take place within the next 2 weeks. This event, called a supernova, will mark the end of Betelgeuse's life. Nevertheless, it will offer a unique chance for scientists to focus on one of the universe's most remarkable and powerful occurrences as a supergiant nearing its demise. Betelgeuse is categorized as a red supergiant, one of the most massive and expansive types of stars in the cosmos. It has been under the scrutiny of astronomers for a long time, but only recently have its fluctuating levels of brightness fueled theories that it is about to undergo a supernova. When a star like Betelgeuse reaches the final stages of its existence, its core collapses under its own gravity, resulting in a massive explosion that sends out a remarkable amount of energy, radiation, and stellar debris into space. Betelgeuse's impending Type 2 supernova-specific kind of explosion that happens when the core of a massive star collapses will be incredibly intense. This core collapse causes the release of neutrinos and radiation, producing a shock wave that rips the star apart. The blast will be so bright that it may be visible from Earth without the use of a telescope, possibly even outshining the moon in the sky for several weeks or months. While such an event would typically be disastrous if it occurred closer, Betelgeuse's distance of approximately 642 light-years from Earth ensures that, although the explosion will be stunning and inspiring, it will not pose any danger to life on our planet. This occurrence, however, promises to transform our comprehension of supernova and other cosmic events. A supernova is one of the most powerful phenomena in the universe. It's radiating more energy in a few moments than the Sun will over its entire lifetime. Betelgeuse's spectacular demise will not only be a magnificent celestial event, but also an important milestone for science. Experts are eager to observe this captivating spectacle from the very beginning, using a variety of ground-based and space-based telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope. To collect as much information as possible, when Betelgeuse explodes, emissions will range from visible light to gamma rays. One of the key aspects of the supernova surge will be the release of mysterious subatomic particles called neutrinos, which rarely interact with matter. These neutrinos can actually reach Earth before the light from the explosion due to their ability to pass through almost anything unimpeded. Facilities like Japan's Super Ice Cube and Canada's Snow Lab in Antarctica are preparing to detect these neutrinos, which would offer an early opportunity to observe Betelgeuse's final moments. The explosion will also provide crucial insights into how heavy elements are formed. When stars explode, they produce and disperse elements like iron, gold, silver, uranium materials, essential for life as we know it. Studying Betelgeuse's supernova will provide real-time insights into this element creation process, essential for understanding the development of planets and the chemical makeup of the universe. While Betelgeuse's explosion is not expected to harm Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy surge from the blast, particularly the influx of cosmic rays and charged particles, could lead to more intense auroras, expanding the regions where the northern and southern lights are visible. Though these cosmic rays may impact satellite communication and some technologies on Earth, the disturbances are predicted to be minimal and short-lived. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to people all over the world, not just professional astronomers with advanced equipment. For several weeks or even months, Betelgeuse is likely to be the brightest object in the night sky. It's possibly even visible during the daytime. This breathtaking event will captivate not only the scientific community, but also amateur astronomers. And the general public, reviving widespread interest in astronomy and the cosmos. Astronomers have speculated for a long time about Betelgeuse's end. But Brian Cox's recent remarks have added a sense of urgency. Worldwide observation centers are gearing up to examine every stage of the explosion. The research collected from this supernova will be invaluable, potentially modifying our understanding of stellar evolution, core collapse, supernova, and the distribution of cosmic matter. The explosion will offer an unprecedented opportunity to improve our measurements of cosmic distances. Being relatively close to Earth, it provides a unique chance to study how energy from such explosions travels through space by monitoring the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust. Between stars, astronomers will gain a more precise understanding of the universe's scale. Specifically, this event will allow scientists to explore dark matter and how it might affect supernova dynamics. Dark matter, an enigmatic substance believed to make up about 85% of the universe's mass, does not emit or absorb light, making it incredibly difficult to detect. However, observing how light and matter behave around Betelgeuse after the explosion may offer indirect clues about dark matter's role in shaping the cosmos. Betelgeuse's supernova will also bring us closer to comprehending the life cycle of stars, especially how large stars contribute to the creation of elements essential to life. Supernova are the primary events responsible for scattering heavy elements across the universe, which eventually form new planets, stars, and even life itself. By studying Betelgeuse, astronomers will learn crucial details about how these elements are created and dispersed. The cultural significance of Betelgeuse's explosion is also noteworthy. For millennia, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the sky will provoke profound reflection on the transitory nature of existence. Betelgeuse has been a constant presence in the constellation Orion for as long as humankind has mapped the heavens, and its absence will serve as a powerful reminder of the fleeting nature of all things. In many cultures, such celestial events have been viewed as omens or symbols of cosmic change. The explosion of Betelgeuse may evoke a mixture of amazement, fear, and awe. As people worldwide witness the demise, this extraordinary occurrence is most likely to rekindle interest in space exploration and astronomy, drawing more people into the search for knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows anyone with a camera or telescope to keep a record of the supernova. This democratization of science will unite individuals all over the world, watching and recording the same cosmic event from their unique locations. Betelgeuse's explosion is not just an astronomical event, but a turning point in future research. The data obtained from the supernova will shape how we study other stars, particularly as humanity ventures deeper into space with missions, seeking understanding of other stars and planets. Understanding the life cycles of stars and the mechanics of a supernova is critical as we seek to expand humanity's presence within the solar system and beyond. Additionally, the blaze will revive our fascination with the search for extraterrestrial life. Supernova are fundamental in spreading the elements needed for life such as carbon and oxygen throughout the universe. By investigating Betelgeuse's explosion, astronomers can better comprehend how the building blocks of life might reach other planetary systems, possibly sparking life elsewhere in the universe. Betelgeuse's imminent explosion is poised to be one of the most important astronomical events in recent history. Its supernova will produce an abundance of scientific data, enhancing our knowledge of the universe while also piquing the interest of people on Earth. Betelgeuse's death will mark the end of a massive star, but it will also represent the continuous cycle of creation and destruction that governs the universe. It serves as a reminder that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event that the world will be watching, attention will turn to the sky eagerly anticipating when one of the most powerful cosmic forces becomes visible to both scientists and stargazers. Betelgeuse's final moments will be truly inspiring. One of the more speculative, yet intriguing possibilities associated with its explosion is the potential to reveal some of the universe's most profound mysteries: dark matter and dark energy. These elusive forces are believed to account for the majority of the universe's mass and energy. Yet they remain largely unknown to scientists. Some have proposed that supernova like Betelgeuse's could hold the key to unraveling these mysteries. Supernova release vast amounts of energy and radiation, and certain researchers believe these powerful forces interact with dark matter in detectable ways. One compelling theory suggests dark matter may exist as massive, weakly interacting particles. If WIMPs do exist, their interaction with the energy from Betelgeuse's supernova could provide vital clues regarding the nature of these interactions. This would be a groundbreaking discovery, offering the first direct evidence of dark matter. Even if answers are not immediate, the upcoming explosion of Betelgeuse will open up new avenues for research. The energy it generates could serve as an innovative experimental environment for studying dark energy. The mysterious force driving the expansion of the universe. By analyzing how energy from the explosion propagates through space, may learn more about the rate at which the universe is expanding and the properties of dark energy. As we await Betelgeuse's death, we find ourselves standing at the crossroads of science and wonder, poised to witness the end of one of the brightest stars in the night sky, with the possibility of gaining deeper insights into the internal workings of the cosmos. The anticipation is not only scientific, but also philosophical, offering humanity a chance to reflect on our place in the vast cosmos. The approaching supernova symbolizes both the death of a star at the end of its life cycle and a powerful reminder of the ongoing processes of creation and destruction that form stars in the universe. Stars like Betelgeuse, which reach the end of their lives in spectacular explosions, leave behind a legacy of elements and energy that nourish the formation of new stars, planets, and possibly even new forms of life. This cosmic cycle is a profound symbol of both the fragility and resilience of the universe, reminding us that even in death, there is the possibility of renewal. For those observing this rare celestial phenomenon, the Betelgeuse explosion will be a once-in-a-lifetime event. It will not only offer an extraordinary opportunity to witness a supernova up close, but also provide a glimpse into the intricate processes of how our universe works. The knowledge gained from studying Betelgeuse's final moments will undoubtedly influence future astronomical research, helping to refine our models of stellar evolution, supernova mechanics, and cosmic distances. As scientists analyze the radiation, neutrinos, and explosion debris, they will gather data that could reshape our understanding of the cosmos's history and its ongoing evolution. Moreover, Betelgeuse's impending explosion highlights the continuous advancement of astronomical technology. With increasingly sophisticated observatories and telescopes, both ground-based and space-based researchers will be able to record this event in unprecedented detail. This upcoming event may even push the boundaries of our understanding of cosmic phenomena, inspiring new technologies and methods of observation that will benefit future generations of astronomers. The explosion of Betelgeuse will also carry significant cultural and historical implications. For millennia, stars have been central to human imagination and mythology. The disappearance of such a prominent star will mark a moving occasion, one that will resonate through cultures, traditions, and stories. The awe and wonder generated by the spectacle will likely inspire artists, poets, thinkers to reflect on the meaning of life, death, and the ever-changing nature of the universe. As the world watches this celestial drama unfold, there is a shared sense of connection, a reminder that, despite the vastness of the universe, we are all bound together by the same sky, whether viewed through a telescope or with the naked eye. Betelgeuse's explosion will unite people across the globe, igniting a collective fascination with the mysteries of the cosmos. It will serve as a testament to the power of human curiosity, the pursuit of knowledge, and our unyielding desire To comprehend the universe in all its grandeur,